Okay, welcome to Chapter 12. This video is going to cover sections A and B. Notice section C is of a different color, so that is only for students taking applications and interpretations. This video is going to be kind of boring because it's going to be a whole lot of just you reading stuff that's on screen. I don't have a lot of commentary to make, so that sounds exciting. Let's begin. Before we even do section A, we've got some basic vocabulary that we need to have a common understanding of. So you are expected to know what each of these bold words mean. Um, Categorical versus quantitative variables. Categorical variables could appear to take on numerical values. For example, I could separate all the students in a school into grade levels, which are numbered 9, 10, 11, 12. But we don't actually measure those numbers. We wouldn't find the average grade level of a student in a school. I don't know, that's dumb. We might as well just call those grade levels A, B, C, and D. All right, so please understand the difference between those two. Um, Census versus sample. A census is when we get things from the whole population. A sample is just from some people of the population. A parameter versus a statistic. A parameter is about the whole population. The statistic is about a sample. We then use that to estimate the population parameter. A ton of overlap here between this and AP Stats, by the way. We are going to look at statistical investigations. Some would call them statistical experiments. That was the terminology I used when I taught AP. This is the process that we're going to go through. In this video, we'll look at the first 3 steps, in particular, choosing the sample and collecting the data. And then later on in this chapter, and in particular in the following chapter, we'll look at organizing and displaying the data, calculating. I know there's probably quite a few of you watching who are excited to see that word pop up here, and interpreting, which many of you are probably not so jazzed about, but I think that's the most exciting part. All right, this page is important. I have nothing else to say about it, so pause the video and read it. Amazing, we're into section A. This page is also important, and I have nothing really to say about it, so pause the video and read it, and pay really close attention to those bold words once again. And here are your other 2 types of error that the course is interested in. So what we'll be looking at in this video is different ways to take samples with the goal of minimizing these error types. Answers to questions will generally take the form of a sentence in which you will explain why a particular sampling method would be more or less likely to result in some of these errors. Let's move on to section B, where we actually see the sampling methods. So our course is going to look at these 5. We need to know the difference between them. So this is the big one. The simple random sample is like the best one as far as we're concerned. And at first glance, the first bullet point here may seem to you like it's like, yeah, of course every member of the population has the same chance of being selected. Well, you'll see in the following sampling types that that's not always the case, but what's really important here is that every set of n members has the same chance of being selected as any other set of n members. So any set of, 3 people from the population is just as likely as any other group of 3. And that is, I think, more obviously less likely from in some of the other sampling types, because some groups are going to be just not possible with some of the other sampling methods, as we'll see. So simple random sample is what we really like, and we're going to often, or I at least, am going to often abbreviate that to SRS. I know that's definitely accepted by the AP. I'm pretty sure that anybody reading an IB test would accept SRS, although I'm not 100% sure at this moment. So in class, that's fine for me. I don't know. The course is still new, so I got to see what the IB takes. We'll see. Systematic sampling. This is when you just kind of have like every other person, every 10th person, whatever. You're using a system, for lack of a better word, to choose a sampling of the population. So we see right away that while every individual here has the same probability of being chosen as any other individual, that would not be true for various pairs. So for example, this one, I'll just highlight its corner, and the one right in front of it, do not have the same probability of being chosen as that one and that one, because the first pair, it's impossible, because we're using a system that would not allow us to choose two consecutive people from the population, or folders, whatever we're talking about in this question. So that's systematic sampling. Convenience sampling, this one, I mean, this happens out there in the real world, but like how often is something convenient also good, right? So we end up, this is going to have a lot of bias. Don't do a convenience sample. Okay, stratified and quota, these two are closely related. So this is basically when we break up the population into subgroups known as strata before sampling. So earlier I made the example of putting people in a school into different grade levels, so that's exactly what we've got here, year 8 through year 12. A stratified sample would then randomly select some people from year 8, some people from year 9, and so on, whereas a quota sample would use some other system, such as a convenience sample, within each strata. There are other sampling methods out there, which I'll just mention this in case you're interested in AP Stats. You've got a voluntary sample when people choose themselves to be part of a sampling. That's definitely opening itself up for bias. We've got cluster sampling, which is really similar to a stratified sample. In a cluster sample, so we might still break people into different age groups or grade levels rather, but then the cluster sample would say, okay, now I'm just going to randomly select one of the clusters to be my entire sample. So I might just look at all of the 10th graders to represent the entire school. That would be a cluster sample. And then we have multi-stage sampling, where we use a combination of a whole bunch of stuff. We'll get into some examples in class together. What I want to do to close out this video is just show you how to actually take a simple random sample, because that's not an obvious thing. I mean, how do you actually ensure that you're randomly sampling? So I'll show you 2 different ways, 3 I guess, and they all involve, first of all, assigning a number to every element in the population. So if there are 9 or fewer elements, then we can, or 10 actually, then we can just give a single digit assigned to each element of the population, starting with 0 and then all the way up to 9. If there were between 10 and 100 elements in the population, then we would give a 2-digit value to everyone. So we start at 0, 0, 0, 1, 0, 2, all the way up to 9, 9. And then similarly for you know, if there were 3 digits worth of people, we start at 0, 0, 0 all the way up to 9, 9, 9, or, you know, stopping at however many people there are. And then we can use one of the following ways to randomly select numbers associated with the members of the population. And assigning the numbers to the people in the population, you can use any method you want for that, because we're going to totally randomize it in the actual selection of which of those numbers we end up using in the sample. So the first one I'll show you is on the TIA NSPIRE. And so we're going to go to the calculator screen, and we're going to go to Menu, Probability, Random. We'll go to Integer, and then we'll choose the lowest integer assigned. So I say we should start at 0, and then whatever you get up to. So I'll go to 9,999. Press enter, and there you go. It gives you a random integer. And then we can do it again. It'll give us another random integer, and again, and so on. Now the fun fact about this is if you've never used this function before on your TI NSPIRE, or actually on your 84 as well, if you use the same, if you use the random integer generator there, and you choose from 0 to 9,999, you will have just generated the exact same 3 numbers as I have. Because nothing's really ever random, is it? So yeah, so there's a process that's put into the calculator to choose random numbers, but it has to still follow its own rule. So every single calculator is, out of the box, is following the exact same rule, and they'll come up with the exact same random numbers. There's a way to like seed your calculator to make it give different random numbers than someone else's, but I don't really think that's particularly important for us right now. Another option is just to go to some website with a random number generator. I'm a fan of random.org. That can generate things for you. We see that the process that random.org is using is different from the one that TI used, because that's pumping out different numbers, so that's great. And the third option, this is a little more old school, is to use what's called a table of random digits. So here we have a whole bunch of digits which have already been randomly concocted somehow. They're broken up into groups of 5 just to make it easier to look at. There's no significance to the grouping of 5. They could have been in groups of 2 or 3, or there could have just been a long string of numbers. That doesn't matter. And over here, they're labeled line 101, 102, 103. That's just to give us something to communicate, like, hey, I'm gonna use line 117. Okay, so I look down here, 117. I know I'm going to start there. And in fact, let's say I start at line 117. If I wanted to choose 3 random integers, and let's see, I was going between 0 and 9,999 before. So these would have to be 4-digit integers each. The integers that I see in this line are 3,816, 7,985, 3,262, and 1,837. I think I said 3 integers and I just chose 4, whatever, you get the idea. It's possible, in particular, when you're dealing with smaller integer values, like smaller place value, if we were just looking at like 2-digit numbers, for example, and if I was choosing a very large sample, that sometimes a number might repeat itself as you go through the line, and that's okay. You would just skip that number and then move on to the next one. So that's 3 methods to choose random digits. I don't know if the IB is going to expect you to be like fluent in describing these methods, but I know that AP does, and it's quite possible that the IB will, so I think it's worth us thinking about it a little bit here. So that's the end of sections A and B. Like I said, it's a lot of reading, and the answers are going to be a lot of writing, but I don't know. I think this is cool. It's a branch of mathematics that you're probably not that familiar with, so it'll be a way of thinking that will be new to many of you. So yeah, let's have fun. So as this video was our first little foray into the mathematical world of statistics, I thought that an appropriate quotation to close with would be the one that our little friend in this comic is saying on screen now. It's a cute little line, and it speaks to the fact that, as you'll see as you get farther into statistics, if one chooses statistics wisely, one can deliver very different narratives about a set of data or about a situation out there in the world. Now, I actually thought that it was Mark Twain who originally said this, but it turns out Mark Twain, in his own writing, attributed it to Benjamin Disraeli. And it turns out I'm not the only person. In fact, most people, I think, probably attribute this quotation to Mark Twain. And in my researching it, I came across this comic that even makes a joke about that fact. And so, you know, haha, it's a joke about statistics being lies, and then this guy busts out a statistic. I thought it was clever. I thought it was even more clever that the comic then goes on to like make a joke about that. I don't know. I liked it. It's kind of lame, but you know. All right, I'm gonna go now.